Hi guys, it's Miss Craft with Honors Algebra 2. We are doing lesson 6 during the asynchronous time, so you should be watching this before your class with your teacher. Today we're going to be talking about linear system applications. So systems of equations coming from word problems, setting them up, and solving them. So students will be able to deduce applicable information by solving a system of equations that pertain to real-world situations. Let's get started. So again, if you'd like to pause me at this point, read through the problem yourself, see if you can get it started, start me up again, then see how far we've come and see if we're matching up, and then at the end see if we get the same answer. I think that's the best way to study. Also, the note catcher is available online, so if you guys want the note catcher to print out before we start the lesson, that's another good option for studying. So let's read through this. We've got two camera types. We've got camera A, and it costs $47 and uses 2 batteries. Replacing those batteries costs $11.50 per year. Then we've got camera B. It costs $59 and uses 1 battery for $4.95, and that battery will last a year. So our variables here, they try to trip us up a little bit. They tell us year and year. And then they say 2 batteries right here, but then they say it just costs $11.50 to replace the batteries. So we're talking 1 battery here. We don't really need to pay attention to this too. So let's set up some equations here. We've got camera A, and we'll just call it the cost of camera A. We know the initial value of the camera before batteries is $47. And then we know that it's going to cost $11.50 per year. So remember, per usually is an indicator that we have a variable. This is our rate of change. So now we can go to the cost of camera B. So we'll call that C again for the total cost. And then we know it costs $59 and we have to add $4.95 per year for cost of batteries. Now they want us to solve. We have been working on solving all week, so if you'd like to set this up algebraically, I think that's a good idea. If you'd like to use Desmos or a graphing calculator, I think that's a good idea. Elimination would probably be the hardest thing to use at this point in this question. But if you want to pause me and then come back to me and fast forward, make sure we get the same answer, I think that's a good idea. So let's, I'm going to set it up algebraically for you guys. We have C and C, so let's just set them equal, right? We can just use substitution and put this guy in for the C here. So we are going to have 47 plus 1150y equals 59 plus 495y. Okay, and then we'll just go ahead and subtract and go back and forth. So minus 47, minus 47. We've got 1150y equals 495y. Oh, whoops. What did I do with my 47? 47. And then I should erase this because that's wrong. Keep it in line here. And we'll write our 12 plus 495y. Okay, now we need to get our y's together. Subtract 495y. Subtract 495y. Then we have 12 equals 655y. Last step, divide. So we're going to divide by 655, divide by 655. And I think what I got is, where is it? 1.832. And so that is years, right? Now we need to plug this years back in. So we have this guy here plugged back in. So I would just say 47 plus 1150 times 1.832. Of course, you'll be able to use a calculator on these problems because that's silly not to be able to. So you'll have 68.068. So that is the cost, right? When will the cameras cost the same? They're going to cost the same at 1.8 years, right? So they're never actually going to cost the same on the exact year point, but after 2 years they will have cost the same, right? So we can just call that after 2 years, but they start going separate ways, right? So 1.8 years, they cost the same. Which camera is the most cost effective in the long run? So if you plug this into your calculator, you're going to have one go like this for B, and then for camera A, yours is going to go like this, right? Because the rate of change of our camera B is lower than the rate of change of our camera A. So over the long run, camera B is better and cheaper. Sounds like we're having meltdowns upstairs, but I can't start this video over. So it's what it is. So camera B. Next problem. All right, the Lopez family had a rectangular garden with a 20-foot perimeter. So let's just remind ourselves what perimeter means again. Ooh, my pen. Ah! This is fun. Okay, yay, it stopped. Okay, so camera B, or not camera B, perimeter of our garden here. Perimeter is the outside, right? So we can call this the length, and we can call this the length. That's an L, and then a W and a W. So there are lots of ways to write that equation. You can write W plus L plus W plus L equals 20. I would prefer just writing 2 lengths plus 2 widths equals 20. That's what we know. Now, they enlarged their garden to be twice as long. So now their new garden is 2 of these, right? So now we have 2L. And if it's twice as long on that side, then that means it's twice as long on this side, right? And 3 feet wider than its original. So that means it's going to be W plus 3 over here and W plus 3 over here. Okay? So now we can represent this guy. Well, we have 2L and 2L, so we can write this. If you'd like to condense it right away, I recommend you doing that. But for people that aren't ready for that, let's write it this way. So we've got our width, and then we have our other width on the other side, and we know that's all going to equal 40. So this one condensed is 4L plus 2W plus 6 equals 40. So we have 2 systems of equations here, right? We've got this guy, forget how hard it is to write, and this guy. They want us to figure out the enlarged garden has 40 perimeter, and what are the dimensions of the original garden. So in other words, we're looking for L and W, right? So let's figure this out. You could do any combination of things. You could do elimination, you could do substitution, you could graph it. I'm going to do elimination since I did algebraic on the last slide. So let's write that all out. We've got our 2 equations here. I'm going to write this one as 2L plus 2W equals 20. Also, this is a great time to go ahead and pause me and see if you can do it yourself. I'm going to subtract my 6 over there, so I have 34. Now I'm going to set this guy up for elimination. I'm going to use subtraction to eliminate. So 2 minus 4L is negative 2L. And then these guys go away. And then 20 minus 34 is negative 14, which means that L is 7. Okay, now all we need to do is plug this 7 back in to one of our problems up here, right? So we'll have, where's my pen? 2 times 7 plus 2w equals 20. So this is 14 plus 2w equals 20, and 2w equals 6, and w equals 3. So the length and width of our original garden is 3 feet by 7 feet. All right, good time to pause me while we do this problem, and then come back if you need help. So for this problem, we are talking about Superman flying against the wind, and we've got distance, rate, and time. So what I want you guys to always write at the top of your paper is D equals RT. Now, of course, you can manipulate this equation to be D over T equals R, or T equals D over R, but I always remember dirt, right? So D equals RT. You can set up a table with that. You can just remember you need a D, an R, and a T assigned over here so that you have 2 of those and you're solving for 1. So Superman flying against the wind. When Superman flies, he has a speed, right? Let's just call it Superman's speed is S. And then we have the wind. Now, when I'm running against the wind, it makes me go slower, right? So I need to subtract that wind speed out of there. And this is going to equal Superman's rate. Okay, it says over here we have time that he went 5 hours. It also says that he went a distance of 400. Okay, so for this equation, we basically have 400 equals S minus W times 5, right? D equals RT. On to the next one. So the return trip with the wind, so now Superman's speed is with the wind, and that is his rate, because wind makes you go faster. If I have a wind behind me pushing, I'm going to go faster than my actual flying speed or my running speed. And so then it takes him only 2 hours. So now his time is 2. And he's still flying the same distance of 400. So now we set this guy up. We've got 400 for the distance, and that we need to include our rate, which is S plus W times 2. Now we have our 2 systems of equations, 1 and 2. I would go ahead and simplify these, right? Because we got multiplication here, and I like that 400 is divisible by 5, and I got multiplication here, and I like that 400 is divisible by 2. So I know this guy is going to be 80 equals S minus W, and I know this guy over here, when I divide by 2, will be 200 equals S plus W. Okay, I would solve for S. We can just add W here and add W here. And now we know 80 plus W equals S. Now we can just plug that in for here if we want to. So we got 200 equals 80 plus W plus W. Okay, so we'll subtract 80 out of there. We have 120 equals W plus W. I gotta go up here, sorry guys. And then so 120 equals 2W, and divide by 2 is 60. Equals 60 for your wind speed. And when you plug that into this W, 80 plus 60 is 140. Equals the speed of Superman. Okay, you have one more problem, but I'm going to get cut off on my video time. So that's going to be on the next video.